Codechef Cook-Off October Division 1. I'm Kamil. Hello. I don't know how to do intro. Starts in 5 seconds. This will be a chill contest, I think. I will comment, I will make drawings for you. I should have plugged in my drawing tablet. Path-etic Sums. Given a tree, assign integer to each node. The sum of values not divisible by the number of them. So two neighbors, they cannot have the same parity. Are there test cases? Yes, so this will be correct. Templates.cpp. Oh, maybe names pathetic. Okay. Yeah, 3 and 4 cannot be neighbors. There must be neighbors. Then for distance 3. Is that easy? I never know if this is sorted by difficulty or not. Find sequence such that the sum over minimum minus GCD is equal to D. If there is 1 in the interval, then this is 0. How's this called? GCD? Let's call it the GCD. Minimum minus GCD. I can get two big neighboring numbers like 100 and 101, and that will give me plus what to the answer? Minimum minus GCD. This will give plus 99. Okay, then what about just using this a lot of times, separated with 1? While d greater than 0, okay, in part, so if I want to achieve x, let's say this, I would say a pushback x plus 1, maybe minus 1, a pushback 1. Let's see what happens. Okay. Oh. I'm not decreasing. This provides the sum of 8, not 10. So what about that? For 10 we have this. Minimum minus GCD. Yes, so should be good. We don't exceed anything. Cool. That D can be 0. Is this allowed? No, it isn't. Let's go. Oh, not registered. Can I make drawings? What is this? Successfully executed. I want to see output. Works now. Yep, I can draw. Cool stuff. Correct answer, yay. Tell me something about this. Okay, people solved the tree problem. So let's do the tree problem. This pen, and we're good to go. One, two. Is it okay if the root is 1, then this is 2, this will be something like a 3 or 1. Maybe this must be related to divisibility by 3. Is this a good tree, no matter how many children I have? And then some fourth layer and so on and so on. This cannot be divisible by 4. It isn't, but it seems to be a coincidence. Oh, I see. If I do this forever, then value of length L, it will have the sum of value around 1.5 times L, so it will not be divisible. Yep. Nice. So just root is 1, children are 2s, and so on. And then because values are 1 and 2, there will be divisibility only if I have only 1s or only 2s, and that's impossible. If the path consists of 1s and 2s, but not just one type, the average value will be between 1 and 2, so no divisibility. I like this. Parent B is not the parent, DFS of B at A. This will flip between 1 and 2. Answer of 1 is 1. What do we print? I can believe that. Submit. Can somebody in the comments tell me what run does? I will appreciate it. Then an interactive problem. I will assume that things are sorted by difficulty. Correct? Up to 2000 queries. Okay, we insert one element in the middle of a sequence, and then we are given information about the number of inversions. Inversion is if it's strict inversion. What's n? 100. So will it be 100 times log of million? Yes, it will be. What will I do? I have some sequence. Now when I insert new value here, let's think. I think I can solve it in n times twice the logarithm, because I need to ask about every number in some way. If I put some number here, like 100, or I put it here instead, maybe the answer will be different by 1. What about this? Put 500,000 here, and then binary search. Where is the first moment that where if you put it there, the answer changes? Then we will get information. What information we will get? That's some strange solution. But if the answer is different for x here and here, it means that the answer is always different. Wait. This is 10, and here I have 5. Then this is an inversion, and this isn't. Oh, so when I have this first number, if I put some value here, and I put it there, the number of inversions will jump by 1. I can binary search this in twice the logarithm by asking still every time about this and that. This is 4,000 queries. Nothing is solved. So what about this other idea? Starting from this, binary search the first place, such that if if you put it there, then the answer will change. Does that make any sense? No, it doesn't. The answer changes even if we shift by 1. Okay, what about this? Start with 500,000 and ask everywhere. This way we know what is small and what is big. Big, big, small, small, small. Okay, and now we need to do some kind of parallel binary search. Or not even that. Just now go to interval of small values, so from 1 to 500,000, those. And now between each of them ask about 250,000 in those positions. Before each of them and after the last one, as long as there is at least one element. I think that this will be nlog. I hope so. Go recursively. Yeah, and consider the fact that you know roughly what this is. So you know after shifting from here to there, by what value everything changes. Now, first, what happens? Is it possible if I shift number from here to there that the number of inversions doesn't change? I think this is possible if this is exactly that particular value. Let's try to code it. Number of test cases, read n. Let's say that n is 5. I need some testing. Let's say that the hidden sequence is this. Doesn't really matter. Have remaining vector of remaining indices to do, initially just all of them, and range for values. Stuff is numbered from 1 to n. Doesn't really matter. From 1 to million, this. There are small and there are big. Eventually we'll do this, low, mid -1, small, +1, high, big. This is some hack. So that I would know what's the number of inversions. Like, if I know that those numbers are big, I can as well set them temporarily to 1 million. So that when I focus on small values, I know what inversions are created. Yeah, exactly. For every index, and just after last index, empty return. Now I can just say before every index, because I added the last +1. I try to put something there. What does query contain? K and X. The number of inversions. Is there insert? Oh, not hidden. No, A. I copied for a reason. Insert here, begin plus k minus 1. In particular for 1, it will be just inserted at the beginning. Cool. We have a query. Those are some queries. What do we do here? Before this should be I plus 1, because for 0 I want to put 1 here. Comma, mid. This is, first it is 500,000. Okay. Now subtract those coming from different stuff. Oh. Okay. Those are mine. For every j, from 0 to I, if not here, and answer of j is greater than mid, minus minus count. I think that's it. Now for two consecutive values, if they are equal, then I exactly got the value right, and otherwise, depending on the comparison, it's small or big. pop back, and now for every I to v size, let's not mess up I and position. I is just index in vector. If queries of I is equal queries of I plus 1, let's think now. If this I think that should be true. They differ just by 1. Now, if I'm bigger, what does it mean? Let's say that I have small values. Then if I have small values like 5, 5, 5, and I'm inserting somewhere a 10, then the number of inversions right now are bigger than here. So this is a case of small values. What is global? Answer is global, doesn't matter. Easy. Queries should be good, right? Okay, 39. What I used is called GDB. This is wrong. This is of size n. So k minus 1 is from 0 to n. C++ insert vector. Before the element at specified position. Zero would be here. 1, 2, 3, 4, 5, 6. Yeah. Okay, 1, 2, 3, 4, 5, 6. For 1, I want this to be exactly a.begin. Yeah. For 6 here, for 7. Oh. So do I need to push back? This seems correct. Let's count queries. That's a lot. Damn it, 3000 queries. No, 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 no. I hoped for 2000. Well. I think I did a lot of unnecessary stuff then. But others aren't doing better. Can I find the set of values in the input by asking about inversions at the very beginning? What about this? If there is a sequence, if I put here value 7 and value 6, and if nothing here is 7 or 6, the answer will not change. I want to decrease million to something smaller. Maybe here I will first manage to binary search all the existing values. So if from 7 to 6 there is a change, it means that one of values here is 7 or 6. This way, gather all the values. How much time would it take? See nlog, I see n plus log. It's tricky to implement. Before going recursively, here, let's find a set of existing values. Let's call it recursion 1. From 1 to million. And let's ask query on 1, 1, query on 1, if I'm using this so many times, then let's create a constant. Big is this. This will go to some interval of values, and it will know for the first and last value what's the answer, what's the number of inversions. And what do I get from this? What do I get? If this, then some kind of set, insert both. what was that? This is bad. Stack Overflow. What about now? If I add here value 20, 20 and 21, so there is one unnecessary value. Hmm. 1 million is kind of missed. So to this set, where is the set here? How many queries? I think it should be n plus log. That's a lot. That's a lot. But the hope is that now I use this set. Low and high will denote indices. This is index again. Values of mid, values of mid. Maybe I missed something. Where do I use low? Oh, this is high. Please be below 2000. Didn't exceed. Can submit theoretically. Okay, let's say that it Try this. I'm very close, but didn't exit here. This is rook. Times. Okay, I made a test where I exceed the limit. Let's think about my first part. Nope, just increased it. Yeah, I made some very ugly hack. For those pairs, if there are two things in a row, just remove the bigger one. Can it fail? I don't think so. Just it fights with some counter tests. Okay, let's write the reading and printing. And I'm ready to go. Oh, because n is very small, I don't need to use long longs. At the end, I should write exclamation mark. Flush, okay. I don't know, this wasn't an easy problem for me, and I still might need to squeeze something here. Successfully executed. Still don't know what that means. How is it going? One person solved that. 2 XOR table. Oof. Such a relief. Okay, let's do XOR table. It's a little bit boring that again we need to find a sequence. Too many constructive problems. Given length. This is smaller equal. This is smaller equal, and there is something special. Okay, x is positive, so this doesn't matter. This will be very easy. Like, let's say that x is 3. Non-negative, yeah. Then I can make some group of zeros and some group of 3s. And the number of pairs I create this way is just count of those, 4 times count of this, 3. Then I make another group, like 4, 4 and 7, 7. This will give me twice 3 to the answer. And this gave me 4 times 3. But I want this length. Oh, just yes and no. So, what's the shortest length with which we can achieve that? I think the problem becomes write the k, or what's the number of stuff? It's k. The problem becomes write k as a times b plus c times d plus and so on, such that a plus b plus c plus d doesn't exceed n. Can be dp. Hopefully it isn't FFT. There are n log n possible pairs. Always I can say plus 1 times 1. Or I can say plus 1 times anything, any x. So with x plus 1 units, I can increase by x. But it is possible that, for example, 100 can be achieved with 20, but 99 maybe can be achieved with worse. Maybe not 98, something like that. Like if this is prime, then it seems much worse. I would be very surprised if we need to use something like this, 1 times 10. No, it's better to use twice 5. need to think. For now, I only see quadratic solution. I can try some hacking, like if the number is 1000, then I will say that, well, something around 30 times 30 is reasonable. I will not try numbers far away from 30. I can quite easily check with brute force. With DP. Let's call it DP problem. Even before reading test cases. DP of 0 for the sum of products I want to get. This will be perfect DP. DP of S is minimum or maximum. I want minimum length. Cool. Let's create some hash out of this. This 45118. And now, what if I change this a little bit? Didn't change. Now it changed. Okay, correct. This doesn't mean a lot for those constraints. So this is correct solution for sure. Increase this 137 481. The end is 481. 396. 233. 230. 07230. Okay. What's the time? It must work up to 300,000. A bit too slow. Can I just do this? Why? Four, 3, 9. Still 4, 3, 9. Okay. Locally, I can run it in 2.5 seconds. That's already not bad. Stop. Start reading the input. X should be ignored, and it just whether the shortest length for this k is smaller or equal n. If yes, say yes. I can decrease this and add some exceptions. Maybe I will see here the running time. Five seconds. Would it work now? They are slower by 50%. Can I also say that I and j should be close to each other? Maybe there should be far away. Oh, no. Is that correct? Did I see that before? It's 439, yes. Okay, that's the key. If j is barely good. Okay, then I have a fast solution. I just don't know why it works. Goal 300,000. Yes, no, yes, okay. That's hopefully 4 problems done, 2 to go. This suggests that if we can fit 4 by 10, we never should do 4 by 9. It's not obvious for me why this is true. But it is. No more than 3 n operations. no commentary for the next 10 minutes because I will eat. So just scroll to, I will remove this red X once I'm done. So you can scroll with arrow to the right by like 10 minutes. I am back. I think we should think about this problem like this. If there is a sequence and two values are neighbors, no, there are two equal values, let's create edges between such pairs of equal values, but I don't need to now draw this edge. Or maybe also this is equal with that, this is equal with this. There's also some final sequence. And with also some requirements. And when I take consecutive k elements, I cannot break or make new connections inside. I can easily break anything that crosses that border by just changing this into some other value. If I want a connection, like right now there is no connection between this guy and this one, I can easily make one, right? By changing this value and whatever is equal to that on the left to this one. If the connections are already the same, can I re-enumerate values? So if the sequence is this, can I make that? Well, and let's say that my interval is of size k equal to 3. It isn't easy. Maybe I should first just break all the connections I can break. Can I do that? Okay, I see an algorithm to just ask once about every interval, change them into some random values. Random means just not occurring in the neighborhood. Then do the same here, there, and so on. And this way, all the connections you can break, you will break. The exception is for connections, some connections we can't break. That happens if k is big. For example, here, because all intervals, they contain the same subsegment, this one, connections within this cannot be changed. And also anti-connections, the opposite of connections. Everything else will be destroyed. assuming that k is small, if everything is different, oh, I can go from the sequence B, get this, right? And I can reverse operations. And I can reverse that part and make this. There would also be some requirement about exact values. So maybe there is one extra step from this, create another sequence, another permutation. Okay, but what about this part? And because this part exists, it also can I still break up connections like that? I can. Those connections will be remaining. So does it mean that no occurs only if k is big, but of course not always? If it was enough to just print yes, no, I would just check if equalities in this middle interval are satisfied, if they are the same. But we need operations. I think I have it just here in the final thing. Or I need to move between two permutations, or just two sequences of completely random values. Let's say that those values are A, B, and now some are repeated. This, and here we have something completely else. 1, 2, 3, 4, 3, 5, 4, 6, 7. I need to make those moves. And I know that this strange thing happened only within some interval like that. So then just keep fixing. Yeah, just keep fixing. Problem isomorphism. With each of them do something special, but remember different stuff. Given two vectors, not exactly, wait. I want to get numbers that were never here. Okay, or can I just keep fixing? No, I cannot. When I do interval like that, just first indices, what about, while I do it, getting this to be some proper number? And changing only u. No, but what happens at the end? They need to be changed to something random. I wanted this function to grab two current vectors and return 100 numbers that are different than those. It will help me a little bit if the numbers here were up to 1 million. Okay, I see. I will grab 200 numbers for A to work with and 200 numbers for B to work with. Among those, find something different than this, that many of them. Good. Okay, now if this, then return dot pushback x. This should work. just say there are some bad things. I want to make it fast because I don't know. Okay, this. I don't know what will be my final complexity. How many do I want? Twice n. This is for a. Now those should just be different than a. The b doesn't matter. Different than this and that. Okay, they will use only those. Now let's work with a. Let's try to make a as different numbers as possible. I want to do something with this interval. Is get unique float for a not present in a of size k. Okay. Replace this interval. This is first step, and the second is just zero this out. Those are some hacks that I don't want to explain. Basically, I want to say if in this iteration I chose mapping for this guy. I don't want to have n times 1000. I'm a little bit scared. I shouldn't though. No. Let's not be scared. If I aim some mapping, okay, this. Let's see what happens here. 2 and 2. This is a 5, right? Okay, seems good. And this will be B. B at the end seems to have randomish values. Still, those two are true and must be the same from the very beginning. Now, if something is still in bad relation with each other, that's bad, and that must be the middle segment. Otherwise, print CS. And that's something. I will need to also save my operations. But now iterate over every part, and what do I do here? The values are distinct here and there. So I will just keep changing them to good values. And there is no harm. Yep. Is it exactly the same code? Not really. L is the start and then new values. This is what to print. The start I will need to print with increasing this by 1 because I have 0 indexing. Then for everything, operation push back the new value. Print pushback operation. No, print of 0. Else. Otherwise I go from the end. And before the change. And additionally I will need to reverse Let's use the trick I already learned. Answer.begin, print of 1.begin, print of 1, and no, this will go at the very end. Pushback what? BFI? I have too many values here. For free. Yeah, what happened? Oh. I twice print the first value. Just once increased by 1. One, two, three, four. So first we change to 14, 15, 1. Then 4, 3, 2, 1. That would already solve the problem. Why am I continuing? 5, 6, 7, 1. 8, 9, 10. Yeah, something's wrong. Very wrong. At the end. Blah, blah, blah. 14, 15, 1, 4, 3, 2. Seems better. What about the very last thing? Okay. Oh, there was a GIF. It's fancy. I don't have time to watch the whole thing, but it's fancy. Nobody solved everything, so still I'm fighting for the win. It's very motivating, you know, when you're good. This feeling that you have a chance for the first place. Even if it happens only once every tens of contests, it's still a nice feeling and some motivation. Yay! The last problem. Let's close all of that. This is square. There won't be even test cases. Is it math? Let G of A denote a graph of n nodes. Okay. The given graph is subgraph. Okay. The graph is described like that. This is a path. Interval 2, 3, 5 will denote 2, 3, 4, 5. B is subgraph. Not subgraph. Count sequences like that, such that the given graph is a subgraph. So if given graph has this interval, so this represents numbers 2, 3, 4, 5, it means that second and third numbers, but they must create a perfect square, then 3, 4 and 4, 5. Non-intersecting ranges. Instead of creating a fancy graph, you can just make drawings for the sample test. Of length 10, 2, 3, 5, 6. Okay. Of length 3. Such that 2, 3 is a perfect square. 1, 1, 2, 2. Okay. Now, if this is a sequence, let's investigate those intervals such that each consecutive pair is a perfect square. The product is a perfect square. Let's say that one number is of form P times Q times R times some squares. Oh, then the next one must be the same, the same, the same. Maybe here times some other prime to 4th power, maybe R is in 5th power, and still each of them must be in the same form. Can I just focus on each part separately and just multiply those? I don't see the point. Would the problem be more difficult with m bigger, just equal to 1? Oh, just this simulates queries in some way, maybe. Oh, but all of them are up to 100,000, so I should just compute the answer for lengths up to 100,000. Okay, I'm given k. What can I do? I can find all primes up to square root of k. Also, maybe I can count primes up to k. That's in k to 2 over 3. K to 28 divided by 3. 9.3. No, what am I doing? 10 at power 9.3, so that's not it. But it seems important to count primes up to k. Let's focus on length 2. What's the number of pairs of numbers from 1 to k such that their product is a perfect square? Yeah, that's a good problem to solve. Count pairs. Count pairs x comma y up to k such that xy, the product is perfect square. So let's say there exists a square root, perfect square root of x times y. Let's count this for xy up to k. Still no solutions. And how much time left? 37 minutes. Oh, nice. Second place right now, just after Gennady. We are the only two with 5 problems. This might be some Project Euler style problem. Every number is good with itself, or okay. A pair is good if it's x comma no. Say that there is some x, then this pair is good. X multiplied by, let's say, 4 times 25, and also x multiplied by 2 to 4th power, so 16 times 49. This pair is good. Basically, all of those, they create one big group. This, and x itself. Numbers, primes bigger than square root of k. Oh, they still can be. Even if something is a huge prime, I can say that p comma p times 4, this is still a good pair. Well, everything x comma 4 times x is good, no matter the value of x. Okay, so I will iterate over GCD of this interval. I think I see a solution for that. Or maybe not. For every value x, I have pairs, no, I have perfect squares of all numbers, 4, 1, 4, 9, 16, and so on. All squares, there will be square root of k of them. Now for every x, I want, if I say that this is set A, I want to count how many there are values a times x, such that a is from this set. Okay, and for a lot of values x, the answer will be the same. No. This is up to k. For So you're fine for all x's up to k. You're fine for x's up to k over 4. You're fine with x's up to k over 9, and so on. What's the time limit? 5 seconds. There might be inclusion-exclusion here, and recently I practiced it, but I still don't see it. And the limits are quite big for any computations, including binomial coefficients, for example. I would guess that they would make constraints lower. It is hard to compute 10 to 7 factorials and inverses of factorials. for every x, just some prefix of that. So there are 10 to 7 different types of x's. There are those for which 1 for 9 are good. I would need to compute how many non-perfect squares are in some intervals. In particular here, if I want x to be good with those, but not with this, I want x in from k divided by 16 to k divided by 9. I don't care now about brackets, whether it's inclusive or exclusive, but if you're in this interval, you're good with those 3 squares. And multiplying by 16 would overflow. Can I count non-perfect squares in this interval? I can count all numbers, and then I would need some inclusion-exclusion. Okay, let's try inclusion-exclusion. If I say that there's some number of those x's, then I will say that each number in my interval can be one of 3 types, so I will say 3 to length of interval. In each of them I choose every number will be x, or x times 4, or x times 9. Why is this incorrect? Because maybe this is also counted as multiples of some bigger x. It must be multiples of like x times 4. So I need to take this with minus. Like, no, not this with minus. And then 36 with plus. For every number up to 10 to 7th, I might need to compute like parity of the sum of exponents, or parity of the number of primes. Depending on that, I will take it with plus or with minus. I practiced this. I should be able to do it. No solutions still. I'm more surprised. Maybe the problem is hard, sure, but I'm more surprised that still we are the only 2 with 5 problems. I don't feel like I did a good job. And I see some strong names. Inclusion, exclusion. So for every x, I added this 3 to 11 to, or whatever, something to 11 to the answer. This is incorrect if each of those multiples is divisible by something. Okay. Let's go with divisibility by 4, divisibility by 9, divisibility by 25, and so on. So just divisibility by square of prime. Because if this is the case for every a, b, and so on, for all the multipliers, I double counted. So I should subtract every x of form x being p squared times something. Then I should add back those of form p square q square, and so on and so on. Also, how do I deal with different lengths? Oh no, because I have queries about lengths. This would create a nice subtask. The subtask is m equal to 1. This is what I can solve, I think. Okay, so what exactly do I do? I compute the answer. I create this vector of squares, just all squares. Then I iterate over all squares for each of them, depending on what can I do about different lengths? I will get like 3 to 11 power plus 5 to 11 power plus this to 11 power. Every term will be this to 11 power. This does not depend on L. Let's say that at the end I get that this is 3 to L1 plus 3 to L2 plus 3 to L3 minus twice 6 to L1 plus this plus this. But instead of 3 there are a lot of those values Li. How do I deal with that? I don't know. I don't know. Hmm. 20 minutes left. No solutions still. So Gennady didn't solve it and he had a bit more time than me. I'm just thinking about giving up now. How to get a list of submissions of somebody. Can I do it? Oh yeah, 16, 5, 111. Finished at 111. I finished at 143. Is the ranking up to date? That's crazy. He had half an hour more and still didn't solve it. Okay, I will see the editorial later. I would fight still here if there was just one query. Seems to be a difficult problem, and I'm not good at project Eulers. I never did that, and it seems to be such a problem. I think it's inclusion-exclusion. Not that it helps. Okay, thank you everybody for watching. See a link in the description for the final leaderboard, but I'm guessing that I will get the second place. It would be, somebody would need to now solve 2 problems. Somebody with 4 problems. This doesn't seem likely. So I'm happy about my performance, and I think this means I will get red. I will get 7 stars in Codechef. That's nice. Yeah, the contest was good. I don't know if I hacked that single problem where I squeezed the running time. Same with interaction. So maybe this explains my good score. Morphism, yeah, I legitimately did. I honestly did it. I solved it correctly. I don't know. Maybe too many constructive problems, other than the last one. But problems were nice. Yep. See link for leaderboard. Bye bye.